So let's go ahead and take a look at another example here of a confidence interval for a proportion. Again, this one is a 90% confidence interval. I'm going to just let you kind of look through this here. But again, we're trying to estimate the proportion of people who think there's only one true love for each person. We surveyed 2625 U.S. adults, 2,625. You can see what we're trying to estimate. We're going to do a proportion z-interval process, which means we're going to end up using the equation here. Oh, I didn't write the equation. Remember the equation from it's p hat plus or minus your critical z, right? There's your z times your p hat times q hat over n, right? And that just came from our previous formula that we had there. And so that's what we're going to be running here. You can see we have the values. Q hat, remember, is the Q hat is the complement of P hat, 28% success. It's large enough, the values are greater than or equal to 10, so we're good there. Simple random sample, and of course 2,000 is less than 5% of the US population, so we're good. We go ahead and plug this in. Again, the most important part is knowing how to plug this in and then the interpretation. So then that leaves us with here, we are 95% confident, that's our conclusion, that the true percent of adults who believe there's only one true love is between 26.6 and 29.4. And we get that from those numbers there. And so that's how we interpret a confidence interval. We don't know what the answer is. We just know that we're 95% confident that it's between those, right? And if our margin of errors are small enough, which in this case is 0.014, then we can kind of narrow down into what the answer is. And again, this is related to what we used to do with our normal distributions and looking at, here's the population, and then we're looking at 95%. So we're getting these two numbers, right? We're getting the lower bound and upper bound here. And there's your 95%. Sorry about that. There's 95% goes right here. And so that's what those two numbers are. And so we would then say that we're confident somewhere between there. But there again, our alpha level is 0.05, that there's a 5% chance that we could be wrong with our estimate there. Example 3 focuses mainly on margins of error. And so again, what is the margin of error under this situation? The margin of error, again, of these equations is this part here. If you look carefully, this is the margin of error. That's your point estimate, p hat, right? Like your x bar was a point estimate. It's just the single value, and then you create it. And so you can get your margin of error here. Remember, a point estimate is right in the middle of a lower bound and upper bound. So when looking at this one here, if your estimate is between 58% and 64%, your point estimate has to be 0.61, where it's right in the middle of 58 and 64. And on the previous lesson, there was a shortcut. I showed you how to do that, right? You do 0.64. I'd rather have you think about it, plus 0.58 divided by 2, and then your answer is 0.61. It's in the middle, though, but I can see what's in the middle. It's 0.61, and your margin of error is 0.03. And then the same thing would happen on this one here, but here the numbers are a little bit harder to play with, but it's very similar. You're going to end up with the same point estimate and then your margin of error. You have these two numbers. You have 0.8484, and then you have your other value over here, which is 0.548. So what we're looking at, what is the value right in the middle of this, right? What's your p hat? What's your point estimate? And the previous lesson was your x bar. And so what's right in the middle is 0.156. How would you get that again? Just add those two numbers. Again, this is the not thinking way. Or again, if you say, oh yeah, I'm just going to find the average of the two numbers, right? You add those two up and then divide by 2. That gives you that middle number, 0.516. And then your margin of error is the difference between 516 and 548, or 516 and 448, right? It's 0.032. If you subtract those, you will see that you get those answers there, right? Whereas that, again, the margin of error is the distance from here to the lower bound and upper bound. And so if you just did this, 0.548 minus 0.516, you get 0.032. So that was the way you'd do it.